The only remark I would make about both of these failures is, again, failures can last a long time. If you look at that, that's a lot of years. If you look at the other one, wherever is the other one, that's even more years. So again, long life helps. Now, there's just two failures. I don't want you to believe that I only had two failures in my life, so I'm not going to go over them, but there's another list of failures which I could talk about if we really want to come back and focus on my failures. But diversions and failures are not the only things to worry about in trying to achieve that scientific goal. There are successes on sub-problems and the fact that these become abandoned opportunities. So the maxim is, if you're going to go for this goal, then you got to solve whatever problems are in the way, of whatever character, okay? So you solve whatever problems must be solved. And if you're successful on those, then your problem is not to be seduced by them, because these will be big successes. Let me give you some examples. List processing is one, okay? Now lists are viewed now as a hot idea. A little old by now. But in those days, nobody believed them, especially the programming systems community. But in fact, they had in it the ideas of list processing as developed early, so this is back in the 1950s. They not only had lists, they had the concept of dynamic resource allocation, they had the notion of data types, they had the full notion of recursion, they had the notion of generators and working with streams. All of those programming concepts were in here, and in fact, after a few years of working, the notion of lists turned out to be very important. As you know, list is important. Big success. The real issue is you can't be seduced into now devoting your life to list processing since it's such a success. And I succeeded in this one, in fact, in the whole efflorescence of a literature, of a scientific literature on list programming, mostly built around lists, but that's irrelevant here, like the FUNOG problem and all the rest of those things. I never participated in this at all. I don't think I ever wrote another article on list processing. So I was not seduced away from my main goal because of the success of list processing. Let's have another one. Hashing. So it turns out that this is not long-lived. This is sort of a month of July in '61. And it turns out that someplace on Long Island or something like this, I can't remember, Marvin Minsky and I happened to be together sitting down with some obnoxious fellow who kept insisting that the only way you're going to build systems that have the right properties is to not program them, but to build new hardware systems, okay? And so sort of there in over the dinner play, we didn't invent, because I'll tell you the rest of the story in a moment, but we sort of used hashing, which was not called hashing at the time, to show that you could do with software direct associative addressing, and you didn't have to build associative machines, which is what this guy was plugging. You could do it all with software, okay? And this was essentially my contribution to this dinner. It turns out that hashing had been invented a couple of years before by a bunch of characters working on a disk system called the RAMAC, in which, in order to deal with the accessing problems, they had invented some clumsy version of hashing. Again, not called hashing. I can't remember what they actually called it. They may have called it scrambled addressing, because that's what I called it. And it took that idea in this very special context, generalized it, saw all the implications of it, was quite clear what all the kinds of things hashing could do for you in the programming world. But again, I controlled myself. I wrote one unpublished paper on this. This is a historical lie, but it'll do for the purpose of this talk. Sent it off to Knuth to put in his book, and then went on from there. Even though it was clear how important hashing was, and in fact, one could have gone off down that hashing line, inventing and developing that technology would have been a fairly thoroughly satisfactory research career. Let me give you another one: protocol analysis. So this, again, this is kind of long-lasting. This sort of goes from 60 to 72, which is a fairly long time. Turns out that one needs, as a sub-project, to go understand the nature of the mind, an appropriate form of data. And the idea behind protocol analysis is to use the natural language content of people talking about what they are, what's going through their mind at the time that they talk. And in the course of working with these early cognitive programs, Herb and I sort of really used that data effectively and reestablished it. It had all been sort of dumped off as the notion of introspection. Introspection was unreliable. We sort of reestablished this. This is a great idea and has in fact made a very large impact in cognitive psychology and cognitive science. I did not follow up on that. What was needed at that point was methodological studies, an attempt to turn protocol analysis into a real engine of research with reliabilities and all the rest of that junk, okay? And I just didn't do that. Now, I'd like to take complete credit, but I did, in fact, right after this period, engage in a period of automatic protocol analysis. That's one of my failures. That came to naught. And so I did not, in fact, abandon things the way I should have, but allowed myself to be seduced into believing that I ought to continue to spend parts of my life on protocol analysis. Now, the fact that when I lift my Vita and all the rest of this stuff, I say, oh, what have I done with my life? Well, I've been all involved in list processing and protocol analysis, and those are two big things. That shouldn't confuse you. All right? I mean, that's just for PR. Okay? What counts is how are you doing with respect to understanding the nature of the mind. And these things are key sub-problems that have to be solved. But as they turn out to be successful, and these certainly were successful, then you got to, in some sense, you got to know to abandon them, give up all the opportunities they offer. I should go talk to Scott Fallman, I'm sure. Give up. That's too deep for most of you, except that Scott has balanced his life between neural net and working on common lists, and he faced exactly these issues. And he and I ought to talk about that sometime. All right. I got one more. Success. This is the whole issue of the efficiency of production systems. What are you going to do when you got 100,000 productions? How are you going to be able to select those rules in a tenth of a second or a hundredth of a second? Now, in fact, we've been working on this from '76, and we're still working on it, so this is really long-lived. There are, in fact, a whole set of important ideas that have developed. This is a little area within the issue now of parallel processing, of the read algorithm, fine-grained parallelism, expensive chunks, unique attributes. Haven't abandoned it yet because we haven't gotten the success out of it that we need so that all of our big production systems are working successfully on parallel processors. I hope I have the courage to abandon it when that time comes. So the points I want to note about this is success can last a long time too, not just failures. But you should never ultimately be diverted. And then that remark that I made earlier, it does help to have a long life because you're going to have 10-year diversions and 10-year successes on some problems. You've got to have some time to come back and work on the main thing. So I'm finally through with all of those, but I need to talk just about success a little bit. So here is successes and their cultivation. And there are two maxims associated with this. One, when you make a success, when you get an insight into the essential problem that you're working on, you'll preserve it. Don't let it go. You work on it and deepen it. In fact, any really deep idea is going to transform itself radically over time and requires the kind of care and tending for that to happen. The reason that's so important is that deep scientific ideas are exceedingly simple, and almost everyone else will see them as trivial. Okay, consequently, you'll be the only one to be able to cultivate them for a number of years. So here's a list of what I consider to be sort of essential good ideas. Kind of unimportant what the list is: list processing, search, symbols, problem spaces, weak methods, production systems, knowledge levels, chunking, impasses, all of which, almost all of which, the story isn't quite the same for each one of them, all of which have this property that they are simple ideas and that over the years, each one of these becomes deeper and transforms itself